When you deploy apps in Azure, you want them to stay responsive and available, even when demand spikes or a virtual machine goes down. That's where Azure Load Balancer comes in. Think of it as the traffic director for your Azure workloads. The load balancer's job is to distribute incoming network traffic evenly across multiple healthy instances like VMs, scale sets, and web apps, so no single instance gets overloaded. If one instance fails, Load Balancer automatically reroutes traffic to the others, keeping your service running without interruption. Now, Azure Load Balancer operates at layer 4 of the OSI model, which is the transport layer. That means it makes decisions based on IP addresses and ports, not on the content of your traffic. It's ideal for scenarios where you just need fast, efficient distribution of TCP or UDP traffic, like balancing requests across a pool of web servers or managing outbound connections from VMs in a virtual network. Azure actually offers two types of load balancers, the public load balancer and the internal load balancer. A public load balancer has a public IP address and distributes traffic from the internet to your backend instances. For example, you might have 3 web servers behind a public load balancer, and incoming web traffic automatically spreads across them. On the other hand, an internal load balancer is used for traffic that stays inside your virtual network. Maybe you have an app tier that talks to a database tier, where the internal load balancer handles that private communication securely. Both types use health probes to constantly check whether your backend instances are responding. If one fails a probe, Load Balancer instantly stops sending traffic its way. When it comes back online, it's added back into rotation automatically. You can also configure load balancing rules that define how incoming traffic gets mapped to backend pool members, including protocol, port, and session persistence options. And one last thing worth noting, Azure Load Balancer is highly scalable and fully managed, so there's no hardware to maintain, and you only pay for the data processed. It's built to handle millions of flows per second with ultra-low latency, making it the go-to choice for high-performance workloads in Azure. If you'd like to see this in action, check out my free hands-on Azure Load Balancer lab at labitpro.com, where you can deploy and test one yourself.